Hi guys, Miss OD again. We have some new rules to look at again today. This time we're going to have our powers that are fractions. So let's start with some things that we already know. We know that a to the power of a half times a to the power of a half would actually be a to the power of 1, because we know our multiplication rule says that we just add the powers. Half plus half is 1. We also know that a to the power of a third times a to the power of a third times a to the power of a third would be also a to the power of 1, because a third plus a third plus a third is 1 whole. But on the other side, we also know that if we have the square root of a times the square root of a, from your work on surds in grade 9, you know you multiply what's underneath the square root sign. So that would give you the square root of a squared, which means you also know that a squared and a square root cancel each other out because they're inverse operations. So you end up with just a, or a to the power of 1. Similarly, if it's the cube root, the rule works the same. You multiply what's underneath the square root sign. In this case, the cube root. So it would be the cube root of a times a times a, which is a cubed. And again, the cube root and the cube cancel each other out. So you're just left with the a. So once again, what we find is we have different answers, or answers that look different to the same question. Here we get a to the power of 1, a to the power of 1. But we see also what we have here, we're multiplying a to the half by itself. Here we're multiplying square root of a by itself. So therefore, we get the same answer. So those two things must be the same. And then similarly, it's for the cube root and the a to the third. We're multiplying a to the power of a third 3 times. We're multiplying the cube root of a 3 times. And we see we get the same answer. So therefore, those two things must be equivalent. So here is the beginning of our first rule. This is, and we could keep going with whatever to the power of a quarter, 1/5, etc. We find the same thing. Notice each time to start with, our fraction is always 1 over a number. So if it's a to the 1/2, we get square root. If it's a to the 1/3, we have cube root. If it was a to the 1/4 or 1/4, we would have the 4th root, and so on. So in general, if you have x to the power of 1 over a number, that's the same as saying it's the nth root. So we can generalize that. Then we can take this idea one step further, because what if that fraction is not always 1 over? What if it's 2 over 3 or 4 over 5? We need to look at this. So what we can do is we say we have x to the power of any fraction where m and n may not necessarily be 1. What we can do is we can use our rules in reverse. So we know that if we have a power inside and a power outside, then we can multiply them. So m times 1 over n would be m over n. Or we can write it the other way around. It actually doesn't matter. We still get m over n. So if I put the fraction power inside, raised to the power of m, I still multiply those powers, and I have x to the power of m over n. Let's go back to this one. That means here, using the rule from above, I take my x to the power of m, but I know that when I have it something to the power of 1 over n, that's the nth root. So that's one way to write it. Or if I take it this way, I know, just using this rule directly, x to the power of 1 over n is the same as the nth root. But then that's still raised to the power of m. Both of these are equivalent. Okay, they are equal. However, this is normally the easiest way to simplify if you don't have a calculator. Because here, if you raise something to a power, you're going to get a bigger number, And then in your head, you're going to have to try and find the nth root, which might be hard. Whereas if you take the nth root first, you get a smaller number, and then you raise a smaller number to our power, which will be easier. So this is probably the better option to remember. But do remember that they are equal. Okay, let's put this into practice. So, the first thing we have to do is write without fractional exponents. So this is just a direct application of the rule. Let's see if we can see our rule on the right here. There we go. So we're just directly applying the fractional power rule. Okay, so this one. So all we have to do is just put a little 5 out the front of the square root. So what we have is then, that is just the 5th root of x. Make sure you do make this small, don't make it look like it's 5 times root x. It's the 5th root. Here be careful because only the x is to the power of 1/4. So that's the same as 3 times x to the power of 1/4. So the 3 is going to stay there as a nice whole number. And then here, just applying the rule directly, the power of the 1/4 is going to be the 4th root. So we put a little 4 there and put your x underneath the square root sign. Now, with the next question, we're applying the second fraction rule because we don't have a numerator of 1 in our fraction. So we're using the other one. Okay, if you need some help, sometimes in the beginning it's easy to separate it. So if you do it as 1/6 and 5, so you put the numerator outside. Remember, it actually doesn't matter which way you put the two powers. Remember, they're the same because 5 times 1/6 is 5/6. Now for this part, m to the power of 1/6, we're using the yellow one here. So that is just the 6th root of m. And then we normally put that in brackets, and that's all to the power of 5. This one we've got some horrible looking fraction, but it's really not as bad as it looks initially. Let's keep the 1 there in the numerator. X to the half, oh, that looks very similar to this one. So x to the half is the same as the square root, so it's just 1 over root x. Done. Now let's go the other way, so giving it without any fractions, write it as a fractional power. So you're just using the rule in reverse. So if it's cube root, it'll be s to the power of 1 over 3. This is the 7th root of f cubed. So if you're not sure, keep the f cubed there for the moment. The 7th root is written as the power of 1/7. And then just multiply the powers. 3 times 1/7 is just 3/7. Here, keep the 1 in the numerator. It's the 5th root, so it's x to the power of 1/5. We could leave it like that, or if we take it further, so we don't even have a fraction, let's use our negative rule in reverse. So if we want to make it so we don't have a big fraction here, we make our power negative and just make the 1 disappear. All right, let's put this into a bit more of a useful sense where we have to actually simplify or evaluate numerical ones. So here we've got 1,000 to the power of 1/3. So it may be easier to think of the cube root of 1,000. So what that means is something times something times something must give us 1,000. Okay. So then what we find is that the cube root of 1,000 is 10. 10 times 10 times 10 is 1,000. Okay, the next one, you've got a fraction and you've got a negative power. So be careful, you've got 2 rules to use this time. -1 tells me I have to use that rule. And then if I just go down a little bit, here with the power, I'm going to use the fraction power, that rule. Do one step at a time, particularly in the beginning. So let's get rid of the negative first. So that means I would have 1 over 81 to the half. Remember, you're doing this without a calculator. So then let's get rid of the half. I know to the power of a half is the same as square root. So that would be 1 over the square root of 81. And then actually work out the answer. Square root of 81. What times what gives me 81? Square root is 9. This one here, definitely not obvious at first. So maybe a good idea to separate it. So separate it so it's 8 to the power of a third, all to the power of 5. To the power of a third, remember, is the same as cube root. And then that's to the power of 5. Cube root of 8, what times what times what gives me 8. That's 2 to the power of 5. 2 to the power of 5, that you should be able to do without a calculator. That's just 2 times 2 times 2 times 2 times 2, 5 times. That gives me 32. Then bringing everything together here, just take your time, don't try and do it in one step. Here, get rid of the negative first. So to get rid of negatives, we put it over 1. So it's 1 over 125 to the power of 2/3. Now let's separate those powers. To the power of a third is the cube root. And then all of that will need to be squared. And then we see we have 1 over the cube root of 25. Something times by itself 3 times is 125. So some of these you should start learning if you don't already know. 5 times 5 is 25. 25 times another 5 is actually 125. So the cube root of 125 is 5. And then we still need to square it. So we have 1 over 25. Okay, let's keep going. Now we've got some fractions and negatives and fraction in the bracket. So you need to remember this rule over here with the negative power and the fraction inside the bracket. That might be useful. So I would get rid of the negative again. It's always easier not to have negative exponents. So using this rule, remember it says flip the fraction upside down and just make the power positive. So that would become 9 over 4. And now we make that a positive a half. Remember, the power of a half over here is the same as square root. So what we actually want to do is take the square root of 9 over 4. And when you have a third, you can take the square root separate. So square root of 9 over square root of 4. So we have 3 over 2. Last one. 1 over the cube root of 27 all to the power of 4. Let's keep the 1 there. Cube root of 27. What times by itself 3 times gives me 27? Well, 3 times 3 is 9. Times another 3 is 27. So that would be 3 to the power of 4. And then, let's see if we can work this out in our head. So 3 to the power of 4 is 3 times 3 times 3 times 3. So this is 9. The 3, 9 times 3 is 27. So then we need to multiply the 27 by 3. If I do 20 times 3 is 60. 7 times 3 is 21. 60 plus 21 is 81. So I have 1 over 81. Okay, these are not too bad, these questions. If you just take your time, don't try and rush it in one step. That's when silly mistakes happen. Good luck. Bye.